So welcome students. So in this question you're given that A is a 3 by 3 matrix which is 1 2 3 2 2 minus 1 and 3 0 k, and f of x is a polynomial x cube minus 2x square plus alpha x plus beta, and my matrix A satisfies the condition f of x is equal to 0. So what can you say about k alpha comma beta? So in this question, if you try to do the general way, that is A is satisfying f of x is equal to 0, this implies a cube minus 2a square minus alpha times a plus beta times I. So if you convert this into matrix polynomial, so with beta you get an I, which is a 3 by 3 I, should be equal to 0. So effectively you need to find a cube, you need to find a square, you need to find a and I. You need to create equations and show that this is null matrix, and from the equations that you get you can find alpha, beta and k. But this is a cumbersome method. So usually these questions, these type of questions, when you're given a matrix and an equation, so usually these questions are based on the concept of characteristic equation. Characteristic equation of a matrix. So what is the concept of characteristic equation of a matrix? It is nothing but every matrix A satisfies its characteristic equation, which is det of A minus lambda I is equal to 0. So every matrix satisfies its characteristic equation, which is A minus lambda I is equal to 0. Det of A minus lambda is equal to 0. So what is A minus lambda I? So if you take minus of lambda times I is lambda 0 0 0 0 0 0. So as you can see, if you take A minus lambda I, you get determinant of, if you're considering the characteristic matrix, 1 minus lambda 2 3, 2 2 minus lambda minus 1, 3 0, k minus lambda is equal to 0. So every matrix satisfies this equation. So this will be a cubic equation in terms of lambda, and A satisfies that matrix polynomial. So some textbooks write it as A minus xi is equal to 0, whatever you want. So this, when you expand this determinant, you get a cubic in lambda. So that will be the characteristic equation of A, and A satisfies that equation. So if you expand this determinant, what do you get? This implies, so 1 minus lambda times, so if you multiply this, you get 2k minus lambda k minus 2 lambda. So minus lambda times 2 plus k plus lambda square minus 0 minus 2 times 2k minus 2 lambda plus 3, 2k minus 2 lambda plus 3 plus 3 times 2 into 0 is 0 minus 3 times 2 minus lambda is equal to 0. So this implies what is the cubic equation that you get? 1 minus lambda into k plus this plus this. So you get minus lambda cube plus lambda square times 2 plus k plus 3 plus k times lambda square, and minus 2k lambda minus lambda times 2 plus k. So if you take minus lambda, you get 2 plus k plus 2k, that is 2 plus 3k. 2 plus k plus 2k is 2 plus 3k and plus 2k. So this is a multiplication of this. Next you have plus 4 lambda minus 4k minus 6 minus 9 times 2 is minus 18 plus 9 lambda is equal to 0. This is a characteristic equation. So effectively if you write it in a general way, this implies minus lambda cube, and what are the lambda square terms you have? Plus 3 plus k times lambda square, and with lambda you have plus lambda times 4 lambda plus 9 lambda is 13 lambda. So you have a 13 minus 2 minus 3k. So 13 minus 2 is 11 minus 3k. And you have a constant term as, so 2k minus 4k is minus 2k, minus 18 minus 6 is minus 24 is equal to 0. So this is the characteristic equation of this matrix, and if you uniformly multiply the whole equation with a minus, so you get lambda cube minus of 3 plus k times lambda square plus 3k minus 11 times lambda plus 2k plus 24 is equal to 0. So this is the polynomial which A satisfies. Now if you compare these two, so A cube, lambda cube, so 3 plus k has to be equal to 2 by comparison. So the first equation is 3 plus k has to be equal to 2, so k is equal to minus 1. K is equal to minus 1. So once you get k is equal to minus 1, the second equation is minus alpha is equal to 3k minus 11. So minus alpha is equal to 3k minus 11. That is, if you put k is equal to minus 1 is equal to minus 14. So alpha is equal to 14. So you get alpha is equal to 14. Now beta, so the constant term beta is equal to 2k plus 24. So k is already minus 1. So 24 minus 2 is 22. So these are the three values of alpha, k and beta. Thank you.